Next test is the alternating series test. So this is when we have a series that switches between a positive and a negative, okay? And so you have to switch back and forth between positive and negative. It can't go positive, positive, negative, negative. You have to switch positive, negative, positive, negative. So they're set up like this. We're going to say an alternating series. So a sub n has to be greater than 0. And then the part that alternates is the -1 to the n power or the -1 to the n plus 1. So it depends on the n plus 1 will make the second term the negative, whereas just the regular n will make the first term negative if we're starting with n equals 1. I know, it's a little confusing. Okay, so what we know is that if the limit as n approaches infinity of a sub n is equal to 0, like the nth term is equal to 0, and the second term is smaller than the first term, smaller than or equal to the first term, then the series will converge. Okay, so if it's like decreasing, then it'll converge. Okay. Okay, so what's going on here? First, we have this series right here, which is the sum from n is equal to 1 to infinity of -1 to the n plus 1 over 1 over n. This is the alternating harmonic series. So it's the harmonic series, but we're going to switch off pluses and minuses. So let's just plug it in and let's see what it looks like. I have -1 to the 1 plus 1, so times 1 over 1 plus, and I am just going to simplify this because why not? Okay, and then I have -1 to the 2 plus 1, which is 3, over 1 over 2, plus -1 to the 3 plus 1, which is 4, over 1 over 3. Okay, so that simplifies to +1 minus 1/2 plus 1/3 minus, this is going to be 1/4. I know, surprise. So what you're doing is switching off signs, and we have the harmonic series. So if I were just to graph this, 3, 4. Okay, so the first term will give me a value of 1. The second term would be subtracting 1/2. The third term would be adding 1/3. The fourth term would be subtracting 1/4. So the negatives take away some of the area under the curve because it's negative. Okay. So what we're going to try, we know that the series alternates. Okay. And then what we're going to try is this. First, we need to see that the limit as n approaches infinity of a sub n, so that's 1 over n, does that go to 0? And when I plug in infinity, that sure does. Condition 1. Condition 2, a sub n plus 1 has to be less than or equal to a sub n. So that looks like a sub n is 1 over n, n plus 1, 1 over n plus 1 would be a sub n plus 1. So I know just looking at my expansion that the second term is smaller than the first. The second term is smaller. The absolute value of the second term is smaller than the first. Or really what we're looking at is just this a sub n part. We're not looking at the pluses and minus. Okay. So we know that each subsequent term is smaller than the one before it. So because of this, the series converges by alternating series test. Okay. Next, this one. Whenever the series alternates, alternating series test might be your jam. Okay. So I can rewrite this series as the sum from n equals 1 to infinity of 1 of n over, I'm going to pull out the negative, so it's -1 to the n minus 1 times +2 to the n minus 1, okay? And then the -2 to the n minus 1 is equal to the 2 to the n over, or times 2 to the -1, okay? So I'm going to push the 2 to the numerator. So I get 2n over, oh wait, let's pull out the negative to the front. So I'm going to do -1 to the n minus 1 times 2n over 2 to the n. Okay, so this part right here is my a sub n. So first condition, the limit as n approaches infinity of 2 times n over 2 to the n. The bottom is exponential, the top is linear, so we know that this is going to go towards 0. So that's condition 1. Condition 2, we have to test to see if 2 times n plus 1 over 2 to the n plus 1 is smaller than or equal to 2 times n over 2 to the n. And if you're not sure, just plug in a value, okay? So let's try like 3, n equals 3. So 2 times 3 plus 1 over 2 to the 3 plus 1 is less than or equal to 2 times 3 over 2 to the 3. Now this doesn't, I mean, we're not sure, or you can expand the function to see if it works. Okay, so I'm testing only one n value, but it does give me an idea of what is happening. Okay, so I get 4 times 2 is 8 over 2 to the 4 is less than or equal to 6 over 8. This denominator is significantly larger. It's always going to be significantly larger by a factor of 2, in fact, than the term before. Okay, so this is true. And so we know that the series converges by alternating series test. Okay, the last one is, oh, this is the second to last. So the sum from n equals 1 to infinity of 1 over n squared times the cosine of pi x. I do not know what's happening here, so I'm going to expand it. We start with n equals 1, so 1 over 1 times the cosine of pi plus 1 over 2 squared times the cosine of 2 pi plus 1 over 3 squared times the cosine of 3 pi. And I think that's enough. So I'm going to simplify that to cosine pi is -1 plus 1 over 4 times +1 plus 1 over 9 times -1. So cosine is just flipping back and forth from the negative x-axis to the positive x-axis. So it's just switching, it's making the sign switch. So I can actually write this series as n is equal to 1 to infinity of, so n equals 1 was negative, so I'm going to start with -1, and I want the power to be odd, so I'm just going to leave it as n since we're starting with an odd power. So when I plug in 1, I get a -1. And then when I plug in 2, I'll get a +1. Okay, so -1 to the n power times, and then I need the n 1 over n squared part. Okay, so we see that the series alternates, so I'm gonna try my 2 tests here, my 2 conditions. The limit as 1 over n squared. That's going to equal 0 because the bottom is going to zero out our fraction. So that's test number 1. The second thing I need to test is that 1 over n plus 1 squared is going to be smaller than or equal to 1 over n squared. 1 over n plus 1 squared is smaller than just n squared, so the series converges by alternating series test. All right, last one for real this time. So I have the sum from n equals 1 to infinity of -1 to the n plus 1 times n plus 1 over n. Okay, so, I mean, really, we could just rewrite this as the sum from n equals infinity, -1 to the n plus 1. So that alternates times n plus 1 over n. So this part is going to be my a sub n. So I'm going to test number 1, the limit as n approaches infinity of n plus 1 over n. And really, these are growing at the same rate. So we end up with a limit of 1, which does not equal 0. Hey, remember, this is just the nth term test. So the series diverges by the nth term test. Okay, so what we know is that if the first condition fails, the limit, so if it doesn't equal, the limit does not equal 0, then your series diverges by the nth term test. Okay. All right, that's alternating series tests. And now we're going to look at some remainder.